Okay, I'm going to talk about the project that I run here at CCL called MIT App Inventor. And what App Inventor is about is, can we get kids to actually make apps that have consequence? One of the things that we've been, that we've certainly been building here, gosh, for 30, 40 years, is just an enormous infrastructure that gives people all kinds of power. And one of the things that we don't significantly appreciate is kids have that power too. So in MIT, we think a lot about graduate students. We think a lot about projects that can make a real difference. And one of the things we forget is that the same infrastructure is now becoming available to kids, or even middle school students can do things that can actually change their lives with the applications that they make. And with all of the hype that's going on about information technology and AI, it's all about kids or anybody being sort of consumers of that technology. And the question is, can we change that so that everybody really can be a creator and make what I call apps that matter? We have a buzzword that we call computational action. Computational action is, can I build things that really have an impact on me as a kid and my life and my family and my community and maybe even my country? Again, that's the thing we don't appreciate. This information infrastructure that we've all been creating really can give lots and lots of people the power to do that, even primary school students. So that's what App Inventor is about. It's about realizing that vision of computational action. Let me give you an example. I don't know if anybody knows where Dharavi is. Dharavi is one of the largest slums in Asia. It's outside of Mumbai. It has about a million people in it. The average income is something like $10 a month. And Dharavi is also home, besides a million people, of the Dharavi Girls for Change. So the Girls for Change in Dharavi are a group of girls aged sort of like maybe 13 to 16. And what they do is they use information technology, and in particular mobile technology, to make things that will have an impact on the Dharavi community to improve their lives. One of the apps they've made, there they are. One of the apps they've made is something called Pani, which stands for water in the language. And what Pani does is Pani schedules your family's time at the community water distribution site. And so what it does is, since you schedule the thing, well, all of you could make this app, right? So we're not talking about incredibly advanced technology. We're talking about linking it to a real meaningful application that has consequence. And of course, it avoids fights, it avoids having to do long wait, and it's especially meaningful to those girls. Because, in terms of collecting water and going to fight with other families, who's going to get socked to doing it? It's the 14-year-old girl in the family who's going to have to do this. So this is something that's enormously directly meaningful to them and their families. But that's what I mean by computational action, right? It says that kids, even in the poorest communities, can create things that have an impact. And of course, the reason for that is the global infrastructure that we've all created that makes this possible. Let me give you another example. You've read in the news over the last year about Moldova in Eastern Europe, which has all of these problems right now being threatened by Russia. But another problem that Moldova has is hepatitis B. And there's a lot of polluted water. It's hard to find good water. And in one of the regions of Moldova, which has one of the very serious pollution problems and hepatitis, there's I think about 4 or 5 high school girls who've created an app to help this and to help people find sources of good water. And what you do, again, it's an app that all of you could make, but the trick is linking it to real consequence. So what you do is you go around, you find a source of water, you pull out your smartphone, you take a picture of it, you fill out a little rating thing that says, is this water good? You answer a questionnaire like, this source is no good because the pump handle is broken. Right? So that's a smartphone app that they've created. But the cool thing, of course, they're not cool to us, but the cool thing is that you now put this on a geographic database like Google Maps, and anybody in the country, anybody in the world, as they're driving along, can use this to find a source of good water. I mean, look at this. So you've got some, 15-year-old girls, 15, 16-year-old girls who've created a national resource. Right? And again, that's the main message I want to give. We should have high ambitions for not only for graduate students at MIT and all of us, but things that kids actually can do that make a difference. Again, so even kids can create valuable national resources with the technology we already have. Let's go to the US. So here's a middle school in Kentucky. And there's the class there made an app called Farm Alarm. Is it up there? Yeah, Farm Alarm is really simple. Like, again, if you could make it, it's a thing that says it's time to take your meds. And this is inspired by one of the girls in that class whose grandfather was getting Alzheimer's. And she said, wouldn't it make a real difference if he had something that'll remind him when to take his meds? Again, a simple app, right? Any of you could make one of these. But the way this girl thought about that is she said, this app I consider a tribute to my grandfather. And I imagine this being used by people at risk of Alzheimer's, all over the world. What she's in what, 5th grade? But she looks at this app as something that relates her personal sense of dignity and accomplishment directly to her family and her grandfather. She said, this is a tribute, right? So again, even kids can draw on their personal experience and use this technology to make things that really, really matter, and they consider an inspiration for themselves and for everybody. So those are 3 examples. Oh, there a 4th one. This one's coming from Hong Kong, where there's an enormous concern in Hong Kong about old people. So there's a lot of consideration about making old people's lives better. So this is done from a middle school in Hong Kong. And what it is, they made a thing called Dementia Care Companion. And it has a bunch of things. It's the kind of things you'd put in, right? So it sort of says, where am I? Can I press a button and it asks for help? Other kinds of things, maybe exercises I can do, maybe instructions. Again, any of you could make this. But the cool thing is that the instructions, as one of these old people, are spoken to you in the voices of your family members. So I looked at this. I don't know about you folks. I've been creating apps for a long time. It never, ever would have occurred to me to do that. But it's the kind of thing that would occur to a 5th grade kid. So the other message around this is not only empowering kids to do things that we might want to do, But when you empower kids, they have a vision of the world that in lots of ways is richer than what we think about. Right? Of course, they got honored in Hong Kong. They got a prize and all sorts of cool things. Speaking of honoring, this is one of our cool things that we like to cite. So Los Fresnos, Texas is a border town with Mexico, where I believe hardly anybody had been to college or had higher education. And one of the middle school classes there said, I want to make something to help our blind classmate. And again, it's a sort of a location thing for walking around the school and kind of tells you where you are. This thing got picked up by Verizon as a really, really cool app and got a lot of publicity. They ended up being invited to the White House and heard Obama giving a talk about what a wonderful example this is. And just remember that happening in a town where almost nobody had been to college. So a real sense of how you can be inspired by, again, taking your imagination, taking a little bit of technology that we've all made and can know about, and thinking about what's really important there and what can really, really, really happen. Here's our current star. Our current star is Gitanjali Rao, who, oh, this is old. This is when she was, that picture up on the upper left is when she was a ripe old age of 12, I think. And what she did is she was inspired by, you probably remember the awful stuff about the water in Flint, Michigan going on. So she was kind of inspired by that. And she said, can I make something like that about the air and have it and make the same kind of sensors? And she did this thing and she sort of built an app. There on the left is when she was 12. Now she's all grown up, and like 3 years later or 4 years later, and she just got selected as Time Magazine sort of Time Magazine Innovative Kid of the Year. And with any luck, she just got she just got admitted to MIT. She has until May to say whether or not she's going to show up. But you know, there you have, you know, a pretty impressive person who can be in our freshman class next year. Here she is, 4 years ago on the Jimmy Fallon show. So again, she's back where she's 12 years old, and she's demonstrating for Jimmy Fallon this thing that she made, and said there are these components and there's these sensors and stuff like that. And she says, oh yeah, and there's an app that you can use. And Jimmy Fallon says, you're 12 years old? And she says, oh yeah, you know, I use this thing to make an app. Remember, 2018 was a long time ago in terms of knowing that kids could make apps. Now you sort of say, well, kids can make apps. But in 2018, that was quite a thing to say, quite remarkable. All right, so those are some examples of things you can do. What are people using? We're running this out of a server in CSAIL, and actually a cluster of things around the world, but the main server is getting run here out of CSAIL. And this turns out to be one of, if not the largest largest used app being put out by MIT right now in terms of usage, certainly in education. Our group is hosting, well, that was in June 22nd, 2022. There were, last June we said, what 1.800K monthly users. I got a more recent one. I just did another thing. If you look now we've got 1.2 million active users a month that we're running out of our research group. And the top 4 countries, you see the US and Taiwan and Mexico and Spain and South Korea, they all shuffle around month by month. It kind of depends when school's in session and things. But for our group, you know, 1 million users a month is no joke. If you think about the stuff, the servers and things that you're running. And it's just sort of amazing that you can pull this off at MIT. It's a wonderful statement about the quality of the people here that you can pull this off. One of the countries you don't see, by the way, on there is China. And the reason is you need to sort of log in with Google authentication to get to our MIT thing. And China, the China Great Wall doesn't allow any kind of network authentication that they don't run. So we made a deal with the government of Guangzhou, and Guangzhou sort of has a clone of our server that they put up that's made for people in mainland China to use. But I can't give you the up-to-date statistics because, you know, things are getting kind of weird with figuring out what's going on in China. But at least the last time we looked, it had 800K users, which is, you know, sort of nothing for mainland China. But we'll see what comes of that. And then there was a survey. There's this place called EdTech Top 40. They look at the top apps that are being used in schools. And this is not just educational apps. This is what schools are using. And so last year they published that App Inventor, MIT App Inventor, you know, coming out of our modest little research group, is one of the top 40 apps that schools are using in the US. So we're pretty proud of that, and it's starting to have a lot of influence. Probably lots of people have seen it. Let me briefly show you what this thing is. How do you create an app with App Inventor? What's this thing that people are using, and what's it like? You know, and how is it that you know, how is it that the 13, 14-year-olds in Dharavi can make apps using it? I mean, basically you get a page, and the page is a place where you can show what the UI of apps is going to look like. So what you're seeing is that UI happening in the browser, and there on the right, you see a phone. The phone is actually live connected to your browser, right? With sometimes either with Bluetooth or with network or all kinds of things. But there's a live connection between your phone and the browser, and you say, "Gee, I want to make an app. I'll put I think you should have a button." So there on the left, you see all the kinds of what we call components that you can put in your app, and I can drag the button, and I can say, I'll put the button on the screen, and I'll say, I can set the text of the button to something, whatever I'd like it to say, but that's a little boring. Maybe I'd like it to be a picture. So I'd like the button to be a picture of my cat. All right, so I go over and select my cat. I'm going to add that in, and I say that's the shape of the button. Right. The thing to notice is at this moment, right there, I have a running app on my phone. Right, so I've got an app on my phone that has a picture of a cat. That's like a button. Of course, it doesn't do anything because I haven't told it to do anything. I want it to do something when I press the button. So I'm going to add some more stuff to it. I'll add a music player. So that's another component that's in there. I'm going to have the music player make a cat meow sound. Now I go over to another screen. This is where I put behavior on. So for those of you who sort of seen drag and drop blocks kinds of things, there are a bunch of them now. Ours, probably the first one to really come out was Scratch, which we do a lot of work with. Mitch Resnick, who started Scratch, was my master's student. And we use the same foundational technology that comes out of Google called Blockly, which is a thing that allows you to drag these blocks around and put them on browsers and things. But in any case, I go over here to what's called the blocks canvas. And there on the left, if I click on button, I see blocks which are all the methods that a button can do. I grab the first one, which says, oh, do something when the button's clicked. So I drag that out. Now I've got a program where it's got a button, and when the button's clicked, it does absolutely nothing because I haven't told it to do anything. But now what I'm going to do is I go and drag what a music player can do. And one of the things the music player can do is start playing what's built in, which is the cat meow. And I drag that in. Okay. So now I've got a running program. It took exactly that long. And what it is, I pull out my phone and I click on the button, which is the cat, and it goes meow. Right. So that's what it takes to make a running program. And of course, there's lots of other stuff I could do. I could add a label to the UI. I could go back to when the button's clicked, I could say when the button is clicked, go out to another component, which is the location server, and change the text of the label to the address that's coming from the location server. And the thing just to notice, which was, oh God, we started doing App Inventor in Google in 2008, and then moved it to MIT in 2010 and brought it out. Easy to say now, but in 2010, now think about what's happening actually under the covers there, right? So this location server is looking at the thing, it's reading the phone GPS. The phone GPS is giving back the lat long, and it goes to a geographic database and finds the lat long and turns that into my address. And there you see it's printing my address here. And now we sort of go, oh, well, you sort of expect that. But boy, that hasn't been that long. There's a lot of complicated stuff that's going on. And all you are saying as the programmer, as the kid, is give me my address. Again, don't lose track of the sophistication of the infrastructure, that we've built and the consequence that has. So our biggest collaboration these days is with Hong Kong. Hong Kong, we've been doing a project with them for 6 years now, I think. It's called CoolThink. And CoolThink is about teaching computational thinking. The really cool thing about CoolThink is Hong Kong came to us. So we didn't go looking for Hong Kong to work with. They came to us and said, we'd like to work with MIT. We'd like to put in a thing to teach computational thinking. And we'd like it to start in primary school. Right, so this is 2009, 2010. And I sort of went, wow. We take it for granted now that primary school kids can be doing this stuff. But 10 years ago, that was a big thing. And what they sort of said is, we think in terms of getting kids and the Hong Kong citizenship being sophisticated about information technology, the place you want to start that is primary school. Right? We don't even believe that in the US now much. But boy, to say that in 2010, 2011, 2012 was quite an impressive thing. So I sort of really jumped that we really need to work with a group like this. And that's now a big collaboration. It's got a curriculum that goes through 3 grades, grades 4, 5, and 6. And we're collaborating with the Education University of Hong Kong, City University of Hong Kong. Education University of Hong Kong is sort of the big place that does teacher training in Hong Kong. It's sponsored by the Hong Kong Jockey Clubs. Anybody ever heard of the Hong Kong Jockey Club? Yeah, you sort of haven't. The reason is they're focused on doing things for Hong Kong. In size, they are about as large as the Ford Foundation. And they are, I think, the second largest philanthropic organization in Hong Kong. And the reason they have so much money is they own the gambling monopoly in Hong Kong. So they have, you go in the city, there are all these places that have slot machines that are owned by the jockey club. They have 2 racetracks and stuff. So it's quite a nice income. And this is kind of a small project for them. Their typical kind of grant is building buildings in Hong Kong. But in any case, they're really focused on this, and they're really focused on the notion, that we all say that you want the citizenry to be sophisticated and creative about information technology. And the cool thing is, for years they've been believing the right place is to start in primary school. Oh, and there's a special event there that I have at the bottom. At the bottom here, I should have put it in not quite ready. We're told that they are going to announce on May 20th, the end of May, the Hong Kong Education Bureau is going to announce that they are going to put App Inventor in all 550 Hong Kong primary schools. So I don't want to announce that too much because it's not exactly signed on the dotted line, but I'm pretty hopeful that's going to happen. So that's going to be a pretty big deal for us. The curriculum goes in grades 4, 5, and 6. It starts with Scratch in grade 4 and then switches over to stuff. There's a big focus on what I call this computational action. And they're starting to, it's already run right now in 32 experimental schools as a pilot. And they're, with this announcement, they're going to spread it over to lots of other schools. So stay tuned in May, and we'll see if this really comes along. Of course, the main thing, if you're thinking about doing computational thinking in education and stuff, is teacher training. So again, we're collaborating with sort of the big teacher training place in Hong Kong. We've trained about 1,500 teachers overall. But in terms of even going ahead at MIT as we are, the big effort is not only technology development, but real teacher education. It's a big need, and people need to focus on that. Oh, and of course they have contests. This is a contest they did, 5 years ago. And what would they have? One of the nicest ones, the winners in high school were 2 high school students in Guangzhou who made some atmospheric sensors to detect pollution, hooked it up to, again, one of these distributed database apps. And you could go into their database any place in China and look at pollution in the region. And the thing that those high school students liked is the stuff that they were doing ended up being cheaper and more accurate and better than what the Chinese government was putting out for people to use. So there they are in the lower right, and their motto was "We can change the world," which I love because that's exactly the message that we're trying to do with App Inventor. And of course, they had different categories. They had there's a primary school category, and kids did things like that. The youngest one was somebody who was 10 years old who made an app called Magic Night in the Museum. And of course, we're doing this stuff from MIT also. So every year we do what we're calling an appathon. So that's what we're running out of CISO. And the last one in August we had what? 1,181 participants from all over the world. And the youngest one, I think, was 8 years old, and the oldest one was 80 years old. So lots and lots of people. And the nice thing, if you look at this graph on the lower right, the blue part of that pie chart are people who said we are beginners. The red part are people who said we've already studied something about app design. So there's enormous opportunity to get beginners, whether it's primary school students or just anybody, to really be learning how to master this digital technology and do things of consequence. And it's not only kids. We're about to start, in fact, we've just started a project in collaboration with the State of Maine correctional system, where we're going to be teaching this stuff to inmates in Maine State Prison. Who, again, some of them are lifers, and they haven't had any of that kind of technology or any of that background or anything. And then the question is, can you empower these folks to really master digital technology and think about what they could make? Maybe they could sell it in a market or something like that, or maybe they could just teach others. So again, enormous, enormous opportunity. I've been spending the whole talk talking about kids in primary school, but it doesn't stop there. It's like anybody who has not had any kind of technical stuff, and even beginners. Where are we going? So of course, one of the big areas for expansion is Internet of Things. Because if you got a mobile phone, there's no end of the devices you can hook to it. So there's an app that we're playing with where you can monitor the moisture and temperature and other things of a plant. And right, nothing special there. You can hook up, you can hook up Arduinos or various kinds of devices to the phone and then control them to the same thing. Here's what it looks like as a block, right? Just so kind of obvious if you've seen it. This is a little event block that says when the moisture in the plant gets below something, 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 do some message. That's what a program looks like when you're controlling IoT devices. And of course, where we and everybody else is going is with artificial intelligence. So there's the beginning of an AI curriculum for, I guess, 5th grade, which is how do you do AI kinds of things? What kind of AI kinds of things can you do? Well, you can do image classification, among other things. Again, if you're not, probably everybody's familiar with it, but you know there's now all sorts of infrastructure on the web that gives access to classifiers and all kinds of things that you know, very sophisticated AI ones, and you can open them up to kids. Here's there's a little app called Peekaboo, which is you look at your phone, and when the phone is recognizing your face, the baby there smiles, and when you hide your face, the baby sort of gets sad and cries. So that's a little demo piece of curriculum that kids can do. Here's another one, because you know there's other stuff on the web. There's pose classification, and here's one that says, gee, can we make an app that is monitoring how well you are dancing? And again, the magic part is that these classifiers already exist on the web. You can do pose classification and things. So there's just the beginning. I mean, the stuff I showed at the beginning may have been cool, but it's nothing like the cool stuff that's about to happen, that's already happening. And of course, the other one is speech. So we've been doing some stuff with Alexa, and we're working with Amazon. And the question is, can we use the same block thing to create what Amazon calls Alexa skills? And so there you see, again, a little event thing that says when a certain intent, right, in Alexa language, you talk about intents and those getting figured, and when you hear some intent spoken, do some stuff. So that's what a block program looks like. And we're working with Amazon. Amazon has just announced this thing called Amazon Future Engineer, which they're trying to get a lot of publicity around. And the idea there is that they will get school classes to create Alexa skills that astronauts would find useful, that have to do with looking at instrumentation, with monitoring my health and all sorts of things. So we're kind of doing that in partner with Amazon. I think NASA's involved in that. A couple of other places are involved in that. So again, that's kind of just getting off the ground. And then the last thing that David's been very involved with, if I can get it to play, I think I can show this video. Right, everybody's talking about Codex and ChatGPT and things like that. Should I try it?
We all know coding a software application is complex and requires time and experience. But what if instead anyone could make an app simply by talking to the computer? With Aptly, brought to you by the MIT App Inventor team, all you need to do is speak. It's as simple as describing what you want your app to do. Tell App Inventor I want to make an app.
Please give me a name for the app you want to make.
Call the app, translate.
Please describe the app you want to make.
Make an app that translates English text into one of 5 selected languages when a button is pressed.
Let me see what I can make for you.
Then, both the app name and description are populated into the code generator window. And with just the click of a button, my natural language description is transformed into a fully functional app. Just like any App Inventor app, I can navigate to the block screen and make any customizations or changes I would like. In fact, editing apps with Aptly is simple. Just describe the change you want to make, like adding Japanese to the list of languages, and Aptly will update the designer and blocks editor accordingly. I can now translate from English to Spanish with ease. Building off the low-code, no-code movement, Aptly fundamentally changes the idea of what it means to create an app. Through the development of Aptly for App Inventor, we hope to enable and inspire anyone and everyone to make apps, regardless of their coding experience. So, what will you create with Aptly?
You want to do that? Talk to David. So you probably, right, so I'm sure you know what's going on with Codex and the no-code movement and all this stuff. And you're probably seeing things that, in terms of industrial programming, you now find people who don't have deep, sort of deep systems creation training that can do all sorts of things. And every VC in the whole world is looking at startup companies who are trying to do this. But now say, what does that mean about teaching programming to 4th and 5th graders? What would it mean in terms of coding if you could do what you just saw in that Aptly video, where all you have to do is describe the thing and you get a working app, right? So I think the computer education world is just starting to imagine what that's like. But anyway, I think it's up to us. Up here at CSAIL, we have an enormous opportunity to imagine what that's like. Right, it totally, I think, can change the ground rules of what we mean by teaching about computation. And it's just starting. Okay, the last thing I want to mention is that we're getting pretty big. You saw last May, I said we had 1.8 million people a month running off our modest little CSAIL research project. And now it's 2.2 million a year. So, growth like that can't come on forever, but it's getting pretty big. And it's getting maybe past the point where we can do this as a CSAIL research program. So we're spinning off a foundation, a nonprofit foundation called the App Inventor Foundation. And the goal of this is eventually to take over that infrastructure and leave the CSAIL project to really focus on research without having to run the infrastructure. So we're imagining that could happen in about 2 years. So if you have any interest in that at all, talk to us. It's run by this woman, Natalie Lau, who got her PhD here in CCL 3 years ago. So there's a place you can get involved if you don't want to sort of formally join a CCL research project. So that's sort of what I wanted to say. Should end with summary, right? We can reach a worldwide community with educational resources of the stuff that we in CCL have already made and already done. And it's somehow combining our technical competence with the imagination of teachers, and especially the imagination of kids, to think what can be realized. And just to end, I'll go in with a quote. This is the 5th grade girl from Los Fresnos, Texas, the town where no one went to college, who was just grabbed by a reporter coming out of having heard Obama saying what her project was. That's this 5th grade girl's impression of what happened, who really gets it, right? If you have imagination and the will, anything's possible. But we already know that at MIT, right? Anything is possible. And so the question is, how do we think about what's anything possible with kids and even older people, like prisoners in Maine who haven't had this technical ability? Anything is possible. Okay, thanks a lot.
Well, thank you everyone for joining us. If you have any questions for Hal after, I will connect you. And if you're watching in the recording later, we will make sure to get you your answers. So thank you, everyone.